Okay, so in this problem here, we know that indium-111 has a short half-life of 2.8 days. So what a half-life means is if I had, let's say, 1,000 bits of something, in 2.8 days later, there'll be 500 left. And another 2.8 days, there'll be 250, and so on and so forth. Okay, so we know the half-life is 2.8. And it's all good for various things, and we're told that this is the differential equation that relates the number of the indium versus how much is there. It wants to show that the formula for K is this particular value. So then we're going to take this and solve the differential equation. So when we solve the differential equation, I know, again, that if I divide by n, dn is equal to minus k dt, and I'm going to integrate both of these. So here I'm going to get ln is equal to negative kt plus c. Doing the natural log or the exponential e using e, I know as n is equal to e to the negative kt times e to the c, which I know e to the c is some constant, which we'll just call it a in front here. Okay, so now show that the formula for K is this particular thing. Well, I know that T being the half-life of the substance. So I know if I start off with A, half of it is going to be half of A is equal to A e to the minus K, and I know T is the length, capital T is the length of the half-life. I divide by A, and then I take the natural logarithm, I get ln 1/2 is equal to negative kt. If I divide by the negative, I get negative ln 1/2 is equal to kt. Using my exponent rules, this is I can put this up here to the negative 1, and so it's ln 2 is equal to kt. And so k is equal to the natural logarithm of 2 over t. A part is done. B part says if n at 0 is 5 grams, and it wants to find out how much is remaining after 1 day. So continuing on here, let me finish off the formula though. So now if I know this is what k is, I know n is equal to a e to the negative ln 2 over big T times little t. Well, I can leave it as that if I want to. Or I could also take this here and I could rewrite this as a e to the ln 2 times negative 1 big T times little t. And then I could actually do this, consider that, which will mean it's a 2 to the negative 1 over t little t. I could leave it either form, this form or this form are equally correct. So I'll use this form here because I've not used it in previous examples. So I'm told that when my first day is 0, my initial part is 5. That means my initial value is 5. So n is equal to 5 times 2 negative 1 over capital T times little t. If I want to find after 1 day, I let little t equal 1. As I'm assuming that it is days because this is in days. I didn't notice it, mention it there anywhere else other than there, so I'm assuming that it means t is in days. And so n will be 5 times 2 to the minus 1 over t times 1, which is going to be 5 times 2 to the minus 1 over t. But I also realize that t is the half-life of the substance, which in our case is 2.8 days. So to finish it off, I can say 5 times 2 to the minus 1 over 2.8. If I throw that into my calculator, I get 3.9 grams.